Morning, guys. So this one is for pre-cal, chapter 5.1, section 5.1. And I'm sure you guys already know the unit circle from trig. Whoever your teacher that you have last year, I'm sure you guys learned about unit circle already. So unit circle is based off the right triangles, 30, 60, 90, 45, 45, 90 degree. So you may notice that this one here. So let's start with that, the terminal side. So this one is a 0, the horizon. So the position for that point here, it's considered 1, 0, and it's a 0 degree or 360 if you go around the unit circle. So over here, the next position would be considered 30 degree. In terms of radian, so that would be considered pi over 6. If you try to convert that to radian. So this one, if you try to find the ratios, so we do know that for the special right triangle, it's 30, 60, 90. So this one is 30, and here's 60, and 90, that'll be the base right here. So according to the ratio, 30 is always facing to the shortest leg, so it's 1. 60 is facing to the longer leg, so it's root 3. And then 90, so it's facing to the longest leg, so it's 2. And according to that Sohcahtoa, for cosine of 30 degree, it's considered adjacent over hypotenuse, so that's why it's root 3 over 2. So this one's adjacent. Okay, so let me just fix this. Okay, so once again, so this one is 90 degree. So this part right here is called adjacent. And then one here is called the opposite. And then 2 obviously is the hypotenuse. So it's adjacent over hypotenuse, so we do have root 3 over 2. And then for sine of 30 degree, which is the y value, so it's 1/2. And then the next position, we do have 45 degree. So just swing an arc here, so that's 45 degree. So the one that we did previously, that was 30. And then for the rest of this, so that over here is going to be 60 degree. So the other special right triangle we have is 45, 45, 90 degree. So here's 45, 45, and 90 degree. So it's 1, 1, root 2. So again, according to the Sohcahtoa, adjacent over hypotenuse, which is the ratios of cosine of 45 degree. So it's 1 over root 2, but try to rationalize it. We do have root 2 over 2. So sine of 45, it's also root 2 over 2. And then cosine of 60, 1/2. And then sine of 60, root 3 over 2. And then cosine of 90, guess what? It's 0. And then sine of 90, it's 1. Okay? So convert the rest of the angle to radians. So we do have this one, pi over 4. Over here, we do have pi over 3. And then 90 degree, pi over 2. So the next one, 120, 2 pi over 3. And you guys might be wondering, well, the ratio for this one. Well, this one is all about symmetrical. We try to do the reflection here. But in quadrant 2, so this one is always considered negative, positive. Quadrant 1 is always being positive, positive. Okay? And then the next position, 145. So this one would be considered 3 pi over 4. Okay, so let me just rewrite that part. So 3 pi over 4. And then down here, 150. So we do have, okay, so 150 is facing across the one like pi over 6 here. So this one would be considered 5 pi over 6. And then down here, we do have pi. Again, the ratio there is symmetrical, okay? So 210. So 210 up here, we do have 5 pi over 6. So this one would be considered 7 pi over 6. Okay, and then 225, so we do have 5 pi over 4 here. Again, it's all about the multiples of pi over 4. 240, so up there we do have 2 pi over 3, then this one would be considered 5 pi over 3. Well, let's see, 2 pi over 3, the next one would be considered, wait a minute, something wrong with that. It's not 5 pi over 3. So 240, okay, so which is facing through this one here. So it looks like that one, it's 4 power 3. And then over here, 3 power 2. Over here, 5 power 3. And then over here, 7 power 4. 330. 11 pi over 6. Okay, and then back to here, 2 pi. Okay. So just refer to the unit circle. So the one that we have for all the line segment here. Well, this one, according to the homework problem, is called a terminal size. So we'll do some example in just a second. Okay, so now let's take a look at the lecture template. So don't worry about the warm-up problem. You can do it. XY table. Use the transformations technique to sketch the graph. Linear, quadratic. Okay, so now here's the one I would like to talk about for the next part of the video here. So in order to figure out the question marks on a unit circle, so this one basically just want to find out the quadrant. So it's given already. It's in quadrant 4. So try to draw the unit circle. So we do have an x-axis and the y-axis. So let's say that you cannot make a round circle. We can always use a tool and then try to come up with a circle. Let's see what I got here. Tool, then math. Well, I don't have a compass here, unfortunately. I guess you have one. Okay, more tool. Okay, so anyway, so this one, I'll just draw it roughly. So we do have a unit circle. So this one is in quadrant 4. Okay, obviously this one doesn't look like a unit circle. It's hard to do that on the tablet. Okay, so let me just erase that a little bit here. Okay, so it's in quadrant 4, so that means it's over here. So there's a right triangle in quadrant 4. And now we do have the given value of y, so it's negative 7 over 25. Well, according to the ratio of y, it's given as opposite over hypotenuse. So that means for the right triangle, let me just zoom that out. Okay. So this one is negative 7, 25, which is the hypotenuse. And then in order to find out the adjacent, we use the Pythagorean Theorem, which is a squared plus b squared equals c squared. So a is missing, so we need to find out what that is. So plus negative 7 quantity square, and then 25 square. So it's negative 7 squared, so it's 49. 25 squared, then that'd be 625. And then you want to solve for a. So 625 minus 49, and that would give you a number. Okay, so that one, let's see. So it looks like it's going to be a perfect square number. Okay, so you're not comfortable doing that, so you can always use a calculator. So let's use a calculator with the decimal. Or you can use the, well, that's just for graphing, or you can use the Google calculator. Okay, so what we got there is 625. 625 minus 49. And then you want to find out what that's a perfect square number. Well, it looks like it's going to be a perfect square number. And then square root of 576. Okay, so square root of that number, 576. It is, so it's 24. So it's going to give you a perfect square number. Okay, so for A, we do have a perfect square number. So that means this part right here is positive 24. Okay, again, A, we just solve it, is positive 24. Okay, so now, since we come up with that 24, so that means for the adjacent here, so for the x value, so it's considered adjacent over hypotenuse because that's cosine of that angle, theta. So we do have 24 over 25 for the question mark. And then the next one is quite similar. So this one is the x-coordinate of p is negative 2 over 5, and p lies above the x-axis. So this one, if you try to sketch the graph, again, we need the x-axis. And the y-axis. So it's lights above, and the x-coordinates negative 2/5. So that means it must be in quadrant 2. So in quadrant 2 here, we do have a right triangle. So for the x-coordinate, it's adjacent over hypotenuse, so it's negative 2/5. And then try to use that Pythagorean theorem. We do have negative 2 quantity square plus b square equals 5 square. So it's 4 plus b square equals 25. So that means for b, it's, well, b squared is 25 minus 4, so it's 21. And then take the square root of this, so b equals positive root 21. So that means for the opposite, it's root 21. Okay, so you want to figure out the y value, because the y value is missing here. So that would be considered root 21 over 5. Okay, so verify the given point lines on the graph of the unit circle. Notice that the unit circle indicates the radius is always 1. Okay, so that's just a hint. So basically this one just used the Pythagorean theorem. So we do have a squared plus b squared equals c squared. So by plugging a number, so we do have negative root 5 over 3 quantity square plus negative 2 over 3 square. So we want to find out what that is. So negative root 5 over 3 quantity square, we do have 5 over 9. And then negative 2 over 3 quantity square, we end up with 4 over 9. Once you combine them, so it's 1. So therefore, the point, it's actually lying on the unit circle, because that it shows the radius, 1. Okay, so now let's see what else that we have for the rest of this. The next slide. So find a terminal point on a unit circle. So we do have pi over 3. So this one basically just use the unit circle. So back to the unit circle chart, the one that I did. Okay, so back to the unit circle chart. So at pi over 3, so which is over here, so the point would be considered 1/2 root 3 over 2. So basically this one just referred to the unit circle. Okay, so root 3 over 2, comma 1/2. And then 11 pi over 6. Again, if you just refer back to the unit circle, it's over here. So it's root 3 over 2, comma negative 1/2. So root 3 over 2, comma negative 1/2. And then negative 3 pi over 6. So this one's a little bit different. So first thing that you want to do, you want to reduce it. So this one turns out to be negative pi over 2. Because what I did here, I divided by 3 top and the bottom. So if the angle is negative pi over 2, so that means you're going by clockwise instead of going by counterclockwise. So negative pi over 2, so it's down here. So 0, comma negative 1. So 0, comma negative 1. Okay. So now the next thing I would like to talk about here is called the coterminal angles. So anytime that you have a big angle, like original or like just a regular angle, so the way to find out any coterminal angle is just simply add 360 degree or simply add 2 pi if that's in radian. So all coterminal angles, so here's the formula for finding that. It's whatever the original angle that you have, either you add or subtract 360 degree or you add or subtract 2 pi. Okay, like that. So now let's sketch the following angle and stand the position xy coordinate. Find the positive and the one negative coterminal angle. So basically this one just sketched at 225. So 225, again, I need the x-axis and the y-axis. So 225, so that would be in quadrant 3 right here. Okay, so 225. So the way to find the coterminal, so for the positive, so basically simply just add 360. So for the positive, once you add 360, you'll end up with, well, let's see, started with the 1. Well, to ones place. 5 plus zeros, that's 5. 2 plus 6, that's 8. 10 place. And then the 100 place, so 2 plus 3, we do have 5. So it's 585 degree. And then for the negative, so you basically just subtract 225 by 360. So 225 minus 360, then you end up with a negative angle. So then that would be considered 10 minus 5, 5. And then you borrow 10 from 6, so that turns out to be 5 minus 2, 3. And then 3 minus 2, 1, so it's negative 135 degree. So for the next one, basically you want to do the same thing. So you might want to try this one here by yourself. So eventually you'll end up with negative 150. Now, got to be careful with this. So this one is negative angle, so that means you're going by clockwise. Again, I need the x-axis and the y-axis. So negative 150, so eventually you're going to end up with the angle in quadrant 3. Okay, quadrant 3 right here. Again, so basically just add 360 to get a positive coterminal. So at 360, you'll end up with, okay, let's see, subtraction, so 210 degree. And then get the negative coterminal, so you want to subtract 150, negative 150 by 360. So two negative number, that means we're doing addition. So eventually 0, 11, 1 plus 3, 4 plus 1, so negative 510 degree. Okay. So now let's see what else that we have for the next part of the video here. Okay, so we do have 2 more slides to go. Okay, so now for example 5, so you want to find all angle data coterminal with the given angle. So negative 45 degree, all the coterminals, so basically just simply add this one. Well, there's a general formula for this, so you want to add and subtract 360 degree times k. So where k is any natural number. Well, natural number, that means it's like 1, 2, 3, 4, 5, 6, 7, the counting number. Well, because on the unit circle, you can go around the unit circle as many times as you want. You can go by clockwise, you can go by counterclockwise. So that's why I can add or subtract 360. Okay, so that's just the indicator, and it shows how many times that you want to go around the unit circle. So for the next one, basically the same thing. So 90 plus minus 360k. So where k, it's any natural number. So make sure that you need to indicate it. So for the next one, you want to draw a 60 degree in standard position and then find the value of b. The point of 2, b, it's on the terminal sides of 60 degree. Again, so this one I need the x-axis and the y-axis. Okay, so the x-axis and the y-axis. Okay, so this one is showing that 60 degree in standard position. So 60, so that's about up here high. Okay, 60 degree. So try to make the dotted line here, so that just, just form a 90 degree special right triangle. So we do know that the point here is 2, b. So 2, b right here. And the thing that we need to find out, it's the value of b. Okay, so one thing that we notice, so 2, which is considered adjacent, and b, that's just the opposite. So in order to find out what b is, we can use Sohcahtoa. Again, Sohcahtoa, back to what you did in trig. So that means sine of the angle, it's always opposite over hypotenuse. And then cosine of theta, ca. So that means cosine of theta, it's adjacent over hypotenuse. And then for tangent, so tangent of theta, so that one it's opposite over adjacent. So according to the ratio that we have, this one is opposite and adjacent. Obviously, we're using tangent. So tangent of 60 degree. So we do have b over 2. So according to the ratios of tangent of 60, so this one is The ratio for that is root 3. This one is 1, so that's just root 3 over 1. So that equals b over 2, and then you cross multiplied it, so that means b equals root 3 times 2, which is 2 root 3. Alright. Yeah, so if you hear any noise there, my daughters are playing out there. Okay, so apologize for that noise. And now let's see what else for the rest of the video here. Okay, finally, we're getting to the last slide. So the last slide showing that the reference angles or reference number. So the way to find the measure of the reference angles or the reference number. So let's say that we do have an angle. We do have 4 different scenarios. So let's say that the terminal side is in quadrant 1. So that means the reference angle is the same as theta. So this one is case 1. So if that's in quadrant 1, so the reference angle is the same as theta. But now what about if the reference angle, well, if the angle is located in quadrant 2, like this. So the way to find out the reference angle, then that would be considered 180 minus theta, or pi minus theta, depends on what theta is. Okay, again, this one's theta. So this one here, case 1, reference angle is the same as theta. And then for case 3, so let's say that the terminal side is in quadrant 3, like this. So the way to find the reference angle, so that would be right here. So then that would be considered theta minus 180, excuse me. So this one's theta minus 180. Okay, so the reference angle is always bounded in between the x-axis and the terminal sides. And then for case 4, so let's say that the terminal side is in quadrant 4, so the angle goes this way. So that means the reference angle is over here to shade the region. So the way to do that, so it's considered 360 minus theta. Okay, so now let's take a look at that, some of the example here. So find the reference number of each value of t. Well, first thing that you want to do, you want to find out the location of the angle. So 4 pi over 3. Well, one thing that we notice that this one is pi over 2. This one here is 3 pi over 2. So 4 pi over 3, we want to convert that to, perhaps you want to convert that to degree first. So 4 pi over 3 times 180 over pi. So I want to convert that to degrees to find out the what the angle is in degree. So pi cross cancel, 3 cross cancel out with 180, so we got 60. So 60 times 4, then that'll be 240. So some people prefer to do it this way because that the number, you know, they use with degree, it's easier. So 240, so that means it's in quadrant 3. So according to that, all the scenarios for the reference number or the reference angle, so it's case 3. So that means 240 minus 180. So that means the reference angle, it's 60 degrees. So try to make the right triangle here. So this one is another special right triangle, 30, 60, 90. So now let's see what about the negative 41 pi over 3. So this one is a little bit different because this one is going by clockwise. Again, first thing that you want to do, you want to convert that from radian to degree. I mean, it's up to you. You want to leave that in terms of pi and then just find the coterminal angle. So pi got canceled. 3 goes into 180, 60 times. So looks like we're going to end up with a big number. So negative 41 times 60. Again, for those who don't like to use calculator, you can always do this. Third grade math or GFA, pre-algebra. 1 times 6, 6. Negative 4 times 6, negative 24. Bring down to 0. So we got negative 2,460. Another thing that I can do here, you can find the positive coterminal angle. So what I'm going to be doing, I'm going to keep adding this one by 180. And how many times do I need to add that 180? Maybe 4 times, 5 times. Okay, so it looks like this one, I need to add 180 many times, okay? So let's start with that 180 by, let's just, well, not just 180. In order to find a coterminal, we actually add 360, excuse me. 180, that just give you like something else, okay? So let's just add 360 multiple times. So let's say that I want to add 360 probably 10 times. So we got 3,600, right? Well, the things that's easier to add it this way, so you end up with a positive angle. So once you subtract, so 0 minus 0, 0, 10 minus 6, 4, 5 minus 4, 1. And then, let's see, what else? 3 minus 2, then that's 1. So I just end up with a big positive coterminal angle. So this one I just subtract. Let's see. 1080. Because I have 360 times. Well, let's see. So 1080, so let's see, 720. So that means I add that 360 twice, and then add that again, so then that'll be 1080. Okay, so just check that, making sure that I'm doing it correctly. 720 plus 360. Okay, so that's 1080. So once you subtract this one, so you'll get 0 for the ones place, tens. You get 14 minus 8, which is 6. And then 10 minus 10, that's nothing. So that means the reference angle would be considered 60 degrees. So just going back to the quadrant, many times, negative 41 power 3. So eventually this one just keep like spiraling. Okay, like that. Eventually it's going back to this quadrant here. So that means the reference angle is 60 degrees. Now, another thing you need to watch out here, because the one that's given, it's in terms of radian. So you need to convert that to radian, whatever the degree that I have. So this one back to the previous one. So I just multiply this one by power 180. Cross cancel. So we get power 3. So this one too. So the reference angle for this one. So it's going to be power 3. Okay, so let me know your thought and any questions that you have for the pre-cal video, the lecture 5.1 today. Okay, so thank you for watching it. And make sure that I try to do some of the homework problem. I know that it's pandemic time right now, so nothing, it's going to be graded for the homework. But in the future, we probably do have some kind of the take-home assessment or the take-home test, and I'll let you know about that in the future. Okay, so you guys take care.